This is a session about Spring 4, the next generation of the Spring framework. And just from a show of hands, who of you is using Spring already? Okay, everyone. Close to. Which version? 3.x versions. Most of you. 2.5, someone? Still stuck with that? Okay. 3.2, getting a bit more precise. 3.1, 3.0. There were way many more people saying, okay, they were using a Spring 3 version, but still. Okay, my name is Oliver Gierke. I work for a company called Pivotal. We're essentially a rebranded Spring Source. We were bought by VMware in 2009 and now spun off into Pivotal. Essentially, VMware and EMC are now our parent companies, and they've pretty much put everything that's open source development and big data development into a new company to move a bit faster, to be a bit more agile, and yeah, to generally improve the way we work, actually, and our products then, in turn, of course. I'm leading the Spring Data project at Pivotal, so taking care of overseeing all the Spring Data modules. There's a talk on one module in the afternoon. I have a reference to that back in the slide deck if you're interested. And I'm also a member of the JPA 2.1 expert group, so in case you have any issues with any JPA stuff, feel free to speak with me how we can probably improve that. Okay. Where have we started, or where do we come from? Most of you are on the Spring 3x timeline. And there are a few core features that actually make up or were important in the Spring 3x timeline. The first one is that we concentrated on an annotation-based programming model. Who of you is using XML for their Java configuration, or for configuration? A few hands only. Annotation-based config? Java config? Someone? Okay. And we've seen this way continuing. So a lot of the new applications that we see started with Spring use the annotation-based component model for their application components and use Java configuration for infrastructure config, like data sources, transaction managers, and what have you, things that you cannot annotate. There's a composable annotations theme to Spring 3x, and I probably just show you that in the. I have a bit of code to back up all the stuff that I want to show you. So when we come from that's the component model. Here's a package with what you see with some components in there. It's a book admin service with an interface and an implementation, a dependency to a repository, and the general theme is that you say, okay, I have my application component declared using annotations, and I can use like at Autowired or the standard at inject stuff to autowire, gosh, these hovers, to autowire my dependencies into my components, and I have a annotation-based transaction management here. It's not really doing something. It's just, okay, this is the way you would work or would write your Java classes, right? There's some external configuration usually necessary. In this case, it's very easy. It's just a configuration class, and I say add component scan. And I can then, do I have a test case for that? I can then go ahead and say, I run this test case with the Spring Test Context Framework, which you're probably familiar with. And I don't even, actually, this is the config class here that we're going to use. And that thing over here, go ahead. That thing, the context configuration, essentially activates this, detects this configuration class, does the component scan, finds the application component, and I get it injected, right? So that's the fundamental way Spring works, or the container works in Spring 3. There's also there was also the introduction of spell. It was back in 3.0, I think. So the ability to have an expression language to refer to external configuration properties, like from a property placeholder configurer, or just generally referring to bean values in a expression language way. There were also quite a few enhancements to the REST and to the MVC framework, especially in the REST area. And we introduced, I think that was 3.2, a model for asynchronous controller invocations based on the Servlet 3.0 async invocation model, right? So just in sync with that, in sync with that, not async with that. All right, so that's pretty much the state of the art. That's where we are. We also have or introduced declarative validation through. I always mix them up. I think the validation one is this one here, the 303. From declarative formatting, I'll show you that in a bit. Caching at cacheable, scheduling, what have you. An important feature of 3.2 was the Spring MVC integration tests, so that you could write in-container application tests for Spring MVC. And yeah, the basic or the major API version upgrades were for JPA 2.0 and Servlet 3. There were, of course, quite a few others, but these were the ones that affected most of the user applications, right? All right. I showed you that in already. I mean, just to give you a bit of a feel, okay, where we start from. So what is Spring 4 all about? So there is like, I mean, the first question is, why not Spring 3.3 or and instead use 4.0 as a new version number? The most important thing is, we had a few discussions about the next version number, and I think I remember Jürgen at one time saying, okay, if we don't make it 4.0 now, we probably will never do, because throughout the history of the Spring framework, there's never been a really breaking new major version. So upgrading from 1.0 to 2.0 was quite seamless. Actually, the changes from 2.0 to 2.5 were much more invasive than they were from 2.5 to 3.0. With the introduction of the annotation-based component model back in 2.5. So we thought, okay, there's a chance to get rid of a lot of stuff like the old Spring MVC. If you remember that simple form controller stuff from the Spring 1 versions, get rid of that. This stuff was deprecated quite a while already, but we actually get the chance to remove stuff here, right? A lot of in this like Spring MVC, the old Spring MVC model, and also support for very old Java libraries. So Spring has been very conservative in dropping support for old dependencies, and this is what we usually do in major versions. Right. Okay. Besides throwing away stuff, I mean, who doesn't like throwing away code? We also add support for some new specifications, and I go into the Java SE story in more detail in a bit. But generally speaking, okay, we have support for JMS 2.0. There's this message context abstraction introduced there. JTA 1.2, which includes a standardized add transactional annotation, which is very close to what you have with the add transactional annotation in Spring already. And I remember the commit, when I skimmed through the commit log, and there was a commit by Jürgen saying added support for JTA 1.2, and it was essentially like 30 lines of code with the new annotation processing, and then 100 lines of code of tests, and that was it, right? So it was very easy to integrate that. In JPA 2.1, it's mostly the unsynchronized persistence context. Who's using that? Okay, you see, right? It's not really a major feature, but okay, we're 2.1 compatible, Beam validation 1.1 compatible, and in the concurrency area, in terms of like task executors and stuff, we've upgraded our support for JSR 2.3.6. So, bottom line of this slide is you get support for all of the latest Java E specifications. That we think are relevant and interesting to use, right? I mean, ironically, that enables you to run these new specifications on containers like Tomcat 6, Tomcat 6, Tomcat 7, like containers that were not really meant to run these specifications, but you can just do it with Spring 4. Okay. Don't think there's a demo for that one, right? Another core theme of the Spring 4 release is more advanced support for Groovy. We always had support for like scripting support to execute Groovy scripts as Spring Beans. But I'd like to show you the Groovy bean builder. So what you can do now, is anyone using Grails here? Only a few people. You probably know that thing then already. It's essentially a port from Grails where you can, let me say, the test case samples are not the best ones. So you can actually just define your bean definitions in Groovy. This essentially creates a company bean, a bean named company with of type string and with the content string source. And what you can, of course, write more complex examples of that. And what you do then is, instead of creating a class path XML application context, you can just run generic Groovy application context and access beans from there, right? So if you prefer writing your beans in Groovy, your bean definitions, that is essentially it, right? Just something taken over from Grails to be used by other applications that or Spring ecosystem projects that want to benefit from that. There's quite a significant change internally that is an extension of what we introduced with the add profile annotation in, was it 3.1, I think? It's a mechanism to define conditional bean definitions. So in some cases, especially for the ecosystem projects like Spring Integration, Spring Batch, and I'll speak about Spring Boot at the end of the talk a bit as well, you often run into the situation that you say, okay, whenever you configure or I want to write code, I as a library developer want to write code that says, okay, whenever you have defined a bean definition, I want to pick that up. If not, I want to maybe create some default configuration for you. Or in a more Spring Boot specific way, if there's maybe a library on the class path, I want to register an additional bean definition, like let's say the Jackson support and stuff that we have. Whenever you have the library on the class path, you get additional functionality. And this mechanism is built into Spring 4 with the add conditional annotation. And that's not really something you probably will use from your application directly, but we've turned the add profile support into an instance, essentially, or one example of using the conditional annotation. It's probably we're getting a bit more into the details if we have a look at Spring Boot in the run at the end of the talk. Okay, composable annotations. I had in the example here. Close that. Yada, yada, yada. Where were we? In this case here, we have the service annotation up here and the transactional annotation here. And I mean, a lot of people just go with add service and add transactional in the first place. And what you can actually do, and I'm not sure, is any one of you using that? That's probably an interesting thing to ask for, is to create your annotations and annotate them with add service and add transactional, so that you find or you get a central point of configuration of that stuff. So if I want to change, assuming I go ahead and say add my application service, then I can get rid of that. And I can now control, for example, where's that? There's probably, I need some disallowed for this. I must define the attribute reader only. Nope, that's the wrong annotation, I think. Oh, yeah. That's it. Okay, application service, right? And this configure, or this setup here would essentially cause the very same thing that it did before. So it's still a service, it's still transactional, but I can now go ahead and configure, for example, the timeout directly at this single place, and that would automatically propagate through all of the usages of application service. Is anyone already using this kind of stuff in applications? Very little people, okay. The reason why a lot of people don't use it is that we effectively have to, like, we hard code the configuration in here, right? And if I want to override this behavior, I have to now go ahead and add the add transactional annotation here again, right? So there's no real way to expose the configuration in a really nice configurable way. And what we've added in Spring 4, that's essentially that thing here, is that we essentially detect the attributes. So we find out that this read-only thing here, because it returns a Boolean, is effectively replicating the transactional read-only flag here, right? So you can more easily go ahead and say my application service in your config, and then define I imported read-only true. That should be false, I guess. Right? So no need for additional annotations. I mean, you could just end up with quite a few annotations stacked onto a class, and it's a more convenient way of reconfiguring that stuff. It's of course also again something that probably the library authors will use more than you from your applications. But if you have bigger applications and you want to have some kind of governance and code style and predefine some or make up some architectural rules, it's very nice to have means like these to actually have other developers work with that. Right. Okay, showed you that. Autowiring with generics. Something that I bothered Jürgen for quite a while with. It's essentially the idea that so far, or in Spring 3X versions, the container wasn't able to inject generic dependencies correctly, right? So let's say you have a plugin of T, like an interface plugin of T, and you write an implementation that says I am a plugin of string and I am a plugin of number, like a second implementation plugin of number, and you wanted to auto-wire that into your component. Spring would still say, okay, there's two versions or two instances for that class. It's probably better to have a look at the code here. The sample I have here is with validators. You can probably tell me whether that is a good example or something. So I have generally a generic type, a validator of some type, and I have a customer validator that just types it to customer, and I have an order validator, right? So assume that's probably, you need this kind of stuff if you, let's say, separate the code a bit more. I mean, right now you could argue, okay, if I want to refer to the order validator, I can just have an auto-wired order validator, period. I'm done with it, right? But if I want to write my client in a fashion of saying, okay, I don't care about the actual implementation, I just want all validators that are validators for order, then in Spring 3X, you couldn't just define, you could, of course, define it like this, but at runtime, you would have got the order, the validator for the customer injected as well, because we only matched the raw type here. And we will do that correctly now. Let's go ahead and say, where's the test case? Generic wiring tests, yada, yada, yada. There we go. Run this as test case, and you'll see that that's broken. Could not auto-wire field client. I've seen that before, no such bean definition. Client. What is in client? Yeah. Let me try that. That's an issue with Lombok, I think. Stop it. It's broken anyway. Saved? Yeah. Try now. Still not working. Why is that? No client found. Let me check what's going on here. Oh yeah, that's probably it. It's in a separate package. I need to copy that over there. That's when you prepare that stuff a minute before you walk down. And then actually move types around and then all the component scanning. And that should work now. Yay, fine. Interesting bit is now that the client has only the auto validator wired here. That's the interesting thing bit actually, because we expressed again, that we want to only have validators of order, and yeah, that's what the container does right now. I mean, I'm not sure that you probably haven't really used this feature before because it just didn't work, and most people didn't really think of it so far. But the bottom line is essentially wiring of generic types works just the way the compiler allows you to assign types to these two variables. So if you can assign something to a validator of order here, then it will be just wired, right? Something that, I mean, if you really need that, it's something that, like other, I'm not sure of any or aware of any other dependency injection containers that actually support that kind of stuff. I showed you that. Hypermedia. I've been working on a tiny library called Spring Helios for a while, which is approaching the problem of hypermedia REST web services and increasing our support for that in Spring MVC. And it's been an external library for quite a while, and we decided to move a bit of that stuff over to Spring MVC because it essentially solves the problem of, where is it? That you have when you try to build links to controllers. Let me check. So let me just comment that thing out. So we have two controllers here. We have a customer controller that essentially exposes a resource for a single customer. I'm not really doing anything because all that matters is that, okay, we have a resource for a single customer, and if I want to essentially express in the order, I have my order model here, and I have a customer, and I want to have an URI in there pointing to the customer. So what I essentially want to end up with, let's say I read up the order here, and the order is for customer with the ID 6. I essentially want to create something like customer /6, right? And if I just go ahead and build that URI myself using Servlet URI Components Builder and what have you, I think it would just work. Servlet URI Components Builder from current request, and then I say path customers. I think it's this way. ID, and then I could do build and expand and 6, right? That would essentially build me the URI to that resource. The problem with that is every time I need to build such a URI, I essentially duplicate the mapping that I've defined here, right? So if I go ahead and change this, or have to change this for whatever reason, I now have to find all of the clients, and the problem is or all of the places that actually build up a URI in a pattern like this. And the problem is that there's no IDE support for that. I mean, you can of course search for customers globally, but that's really, really awkward, right? So what we instead now allow is we have a so-called MVC URI components builder, this thing up here, and it essentially allows you to express, I want to build a URI pointing to that method. And it works just as follows. You say from method call, and you say, okay, here's my controller, customer controller, and this wrapping controller method here essentially creates a fake instance of the controller so that you can invoke, in quotation marks, the method on it. And I say build customer 6. Why doesn't that work? Oh, it's long. And I say build, and I get a URI from that. No, build, yeah, to URI. There we go, right? Okay, how does that work internally? So, I mean, you're probably, hopefully you see the benefit of that is, if I now go ahead and change the mapping, let me just run this bit quickly. That was here, here's the application. I can run that. I'll explain all of that stuff. Yeah, I have to run this Java application, of course. Spring guided tour. Yada, 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 start that. Okay. Localhost 8080 orders 1. Okay. So you see we get the customer's URI exposed, and it essentially follows the mapping here, right? If I now go ahead and quit that thing, go into the customer controller, and I say foo, just change it here, and then rerun the application. Right? So the URI updates accordingly. So I don't have to update the clients. There's also, if you use, let's say, Spring Loaded or JRebel or some similar technology, you don't have to even restart the application container. You can just change the mapping and it will just automatically build up. That's quite interesting if you build REST web services that actually contain links to other resources that you manage. And it's also interesting, we're going to build, not sure we will do that in the 4.0 timeline, but in 4.1 for sure actually, is that if you use JSPs or the JSP tag libraries, that you get a tag where you can essentially express the very same thing, right? So customer controller dot customers here. Something that's probably worth mentioning is that we essentially record the call here and register all of the method parameters that you pipe into the call, so that we can then go ahead and expand that template here with the variable, right? So we're essentially like taking recording the call here and binding the ID to that. It works for path variables, for request parameters, and a bit of other stuff as well. All right, that's the hypermedia support here. Where are we? 35. Okay, got that. Messaging in WebSockets. In Spring 3.2, we introduced the support for asynchronous servlet invocations or controller invocations, and in Spring, it's 4.0 M1, I think, or it was 4.0 M1. We introduced a programming model, a Spring MVC, or a programming model similar to Spring MVC to build a WebSockets application. So what we did to bring this over was to extract the messaging abstractions that you had in Spring integration and coined a new Spring messaging module. That's part of the core framework. And what you now get is essentially a JSR 356 compatible programming model, which adds quite a few of useful stuff. There's some criticism on the JSR about being not really being too low level and not, it doesn't have any support for like the usual fallback strategies that you get with things like sock.js. So building a web application, and if WebSockets is present, it does the upgrade. If not, it does long polling. If that doesn't work, it does short polling. So it mitigates that for you transparently. Right. There is a talk by Rossen, who authored that stuff, under this link here, or behind this link. It's I think a 1-hour webinar, and he really introduces all the details of that programming model. It just looks like Spring MVC. I'm not too much of a WebSockets expert. That's why I just like to forward you to his talk. And yeah, that's essentially part of the 4.0 release as well. Okay, the big bucket of JDK 8 support. Anyone played with Java 8 already? Few hands actually. There's been it's been a bumpy road actually to our support for JDK 8. We wanted to be, we still want to be, of course. Like once Java 8 comes out, you shouldn't have a reason to not upgrade to Spring 4. Actually, we would like you to upgrade much earlier than that. But if you're on Java 8, all the stuff, you should all be able to benefit from all the goodies you get from it already, right? There has been a bit of a delay in terms of, okay, what's the first time we can actually approach it in terms of the Lambda stuff, because they merged it into the master branch quite late. But the bottom line is that the current OpenJDK versions and builds just work fine for us. We don't expect any changes in the areas that affect us too much. But yeah, so if you grab a recent JDK, I think the 1.12 build broke some Javadoc stuff for us, but generally it just works if you're just running it, if you don't build Spring from scratch. A bit of an issue is the IDE support so far. I'll go ahead and show you the samples I have with Intellij. There is a preview support for Java 8 available for STS or Eclipse in general, but as I have an STS here with Groovy installed, and the Groovy plugin essentially patches the Java compiler, and the Java 8 preview patches the Java compiler, they don't actually work with each other. So I'm stuck with compile errors for Java 8 expressions in Eclipse, but that's not something you should be or actually concerned about. So if you want to work with Java 8, I think Intellij is the only reasonable way today. Okay, so what do we have there? I mean, the biggest thing probably everyone waits for is the Lambda expressions in Java 8 in combination with method references, which means I can just use a method reference as a Lambda or as a function expression. There's the new datetime API. We've just updated our datetime formatting stuff that this will work out of the box. Repeatable annotations and parameter name discovery. I'll show you some of that stuff in a second. With Lambda expressions, I guess everyone's aware, right? So what does that mean? Okay, we have SAM types, single abstract method types, interfaces that have a single only method, and you can just get rid of the surrounding. If you want to invoke this kind of code, you can get rid of the surrounding anonymous inner class that you had to write before. The approach actually is quite interesting because Spring always had these, by accident or by design, it had some quite a lot of callbacks in interesting places like JDBC template, JMS template. You have these connection callbacks and stuff, and they are effectively all SAM types, not the templates, but the callback interfaces, which allows us to, or there's actually not really much we have to, or we had to change to get Java 8 Lambda expressions working with the existing types here. So if you have a look at that, for example, so what you previously had to write is, let's say you wanted to, this is your query, or like you want to interact with JDBC. This is your query, and you pipe in a prepared statement setter, which has the only method, whoops, sheesh, all the magic going on here. It has a prepared statement setter down here with a single method. And the only reasonable thing to write here is essentially, or the actual important stuff is that. And for the row mapper, it's essentially that here. Right? And you can shrink down that stuff together with just writing that. Right? You can, of course, argue, OK, there's a bit of, you have to really, if you see this kind of stuff, you really have to know, and there's probably a bit of a challenge for the IDE to make that really consumable and visible, what's actually going on here, right? What is this PS thing actually? What type is it? Of what type is it? And also in this case here, what that actually gets turned into, which is effectively the map row method here. But yeah, quite a lot of, or quite a bit of less code to write in this case. With method references, it just looks like this. You have a look at these two things here. We just have a private method here that is effectively a signature compatible with the row mapper method up here. And if we have that method, we can just go ahead and pipe this method reference into the method parameter that actually takes a row mapper. Right? So this is still the very same query method here, taking a, where is it, query, this one here. It's taking a string prepared statement setter and a row mapper, and the compiler actually now turns this expression here, it just recognizes, okay, we have a signature compatible method, so we can effectively, it's not really what happens, but we can effectively turn this into this anonymous inner class here, or into the same behavior that results from that declaration. That's essentially it for the lambdas, right? So yeah, the existing APIs that take a SAM type should all work out of the box with Java 8 and Lambda expressions. There's been a bit of, or quite a few changes in the reflection API in Java 8. So there's actually a way now to obtain the parameter names from like methods and especially on interfaces. We've used an ASM-based approach previously that read the debug information, the debug symbols from the code that you compiled. Unfortunately, that doesn't work for interfaces because I'm not sure which spec it is, but is it the language spec or the Java spec? It says abstract methods, abstract types must not have debug symbols in them. And is anyone using Spring Data projects, Spring Data JPA or something? You use the interfaces, the repository interfaces quite a bit, and there's no way to actually obtain the method parameters, the parameter names from the method interfaces or the repository interfaces. That has changed internally, so it's if you upgrade to Java 8, you automatically get the better support. So there's nothing you need to activate or something. So the question actually is, should I upgrade? And we actually strongly recommend to upgrade, of course. The major reason for that being that Spring 4 is still compatible with Java EE 6 and 7. I mean, even Java 6 is already end of life officially. We will have a RC in a few days, which actually means tomorrow, I think, at least. The release will be built tomorrow, and it would definitely be helpful to get feedback from your side. Even if upgrade for now means just bumping the dependency version to a 4.0 release candidate and see what breaks. I mean, that's actually the best thing you can do for us, right? And if nothing breaks, I mean, that's even better. But if something breaks, then it would be cool to know before we go GA and act appropriately. Yeah, 3.2 will go into maintenance mode as of the GA date effectively, and yeah, that's essentially it. Okay, that's like it's been the rough overview about the different parts of Spring that have evolved in 4.0. There is this, I don't know if you've seen the announcement at Spring 1 a few weeks ago. There's this new thing called Spring I/O, what we've announced, and that is essentially the idea that we provide you with some kind of foundation or platform of modules that are certified, or Spring ecosystem project versions that are certified to work with each other directly. And the reason I mention that here is that the Spring Framework 4.0 version will be the foundation for this foundation here, right? So what we will do is we will create some kind of a certified set of, like, let's say, all of the modules that we have, Spring Integration, Spring Batch, Spring Data. We will make sure it's very easy to consume them in a coherent fashion. So no more looking up like, okay, I have this Spring version, which Spring Batch version do I need that is compatible with that? And now I pull Spring Webflow in there as well, and which version do I need of that, right? So we will make that very easy, and I'll show you how that works in a bit. And Spring 4 is the foundation or the base of that, of all of that. That doesn't mean the projects will upgrade to Spring 4.0 immediately, so they will not require Spring 4.0 probably for a while, but we will make sure they effectively work out of the box with it, right? On top of the foundation, we actually have like something we call I/O execution, which is okay. This is the library, the core foundation, and we have some runtimes on that on top of that to really build applications of a dedicated like it's big data applications, web applications with Groovy is the greatest part, and there's this new thing called Spring Boot, which I'd like to show you, and that's essentially the glue that brings all of that, all of the modules, all of the runtimes actually together. And there's three aspects to Spring Boot. As I already told you, the primary concern of this I/O foundation is to make it easier to consume a set of libraries, to maybe even certify against a certain set of library versions. So what we want to approach here is to make it easier to find the right set of dependencies for your Spring application. So usually you don't actually want to go ahead and say, I want to build a Spring Web application, let's say with Hibernate and Spring Data JPA. And then you don't want to go ahead and try to figure out, okay, which is the latest Hibernate version that is compatible with Spring Data JPA, which version of my database do I need, and what have you. So that we need to make that easier. The second aspect is that for a lot of the stuff that you bootstrap in a Spring application, there's a bit of default configuration that you have to apply. If you configure Spring MVC, you always have to configure a view resolver. Let's say you decide for ThymeLeaf as your templating engine, then you have to set up a ThymeLeaf view resolver. And for this particular thing, there's probably sensible defaults in the configuration. And actually, the integration of a new technology in your application is usually twofold with Spring. You go ahead and add the dependency to your library, let's say Hibernate and JPA, and then you go ahead and have to configure an entity manager factory, a JPA transaction manager, and maybe, let's say, an in-memory database. Right? It's always like 2 steps of a kind. And Spring Boot will provide sensible configuration that you don't have to do, or you can avoid the boilerplate config setup if you don't want to configure anything extraordinary. But if you want to do that, it will just get out of your way and pick up your actual additional configuration. And the third aspect of Boot is that we want to make it easier to just bootstrap your application, which effectively means that for very simple cases, simple web apps, we nowadays prefer the usage of an embedded runtime. So embedded Tomcat, embedded JD, and yeah. So the application you've seen me bootstrapping a few seconds ago is essentially, what was it? That thing here. Or let me start with the dependency management thing. What we provide you is Maven users. Show of hands. Who's using Maven? Who's using Gradle? The only one, but the highest hand. That's fine. So we support both of them equally. I mean, there's a bit of competition going on right now. The Spring framework uses Gradle for build. We're in terms of the Spring Data projects, mostly use Maven. So there's not really a battle. So we thought, okay, we have to support both. But what we essentially do is we provide you with, in the Maven case, with parent POMs, with starter POMs, and they, like by some levels of indirection, actually have, how do I find it quickly? They essentially wire or define the, let me check that out. There should be a repository, org, Spring Framework, boot, Spring Boot dependencies. There's a POM, right? Right, so we define this set of like compatible versions here, version numbers. We've predefined that for you, and we've also went down the road and using the dependency management tag here to nail down the version. So what you now can go ahead and do is you can just go ahead and say, I have this parent in here, and I can just take HSQL, and I don't have to specify the version. I can just go and say insert dependency, say Spring integration. Does that work? Right. You see all the dependencies here are managed for you by default. That's it. So no need to worry about the right dependency version anymore. If you want to upgrade, you can either go ahead and declare the dependency management tag again, or the easier thing is just to find the right property to override. In this case here, there's Spring integration version. If, let's say, Spring integration releases version 2.2.5 and you don't have an immediate boot release, then after that, you just go ahead and redeclare that version number here and bump that to 2.2.5. But these are essentially the lower version boundaries that you can work with. And what we also provide you with is like dependency sets in terms of, okay, if you want to build a web application, you will probably need Spring MVC, JUnit. For the Spring Data JPA starter, you will definitely use, or you will probably go ahead and use Hibernate and Spring Data JPA, of course. And just by these 2 dependency blocks, you get all the necessary dependencies that you need in the right compatible versions, what have you. The very same works with dependencies in Gradle. There's okay, Groovy syntax, but that's it. The second thing, sensible application defaulting. I have, let's say, the sample I could just show you here is what I do here, if I just went with that one here, the web stuff is actually part of the other demos I gave you. But if I just went with that, all I need to do to actually persist data to an HSQL database, I need these two actually, because okay, we think you want to select the database, of course, is add the JPA entity, right? Add the Spring Data JPA repository interface, and then say, okay, it's my configuration class. I want to do component scanning, and I use this enable auto configuration. And that's essentially the magic trigger here, the light switch. Because that now goes ahead, and when you run the application with boot, when you run the application, it actually inspects your class path. It sees, oh, you've got Spring Data JPA on your class path. You probably want to have Spring Data repositories enabled. Oh, you have used Hibernate as your persistence provider, so we configure a local container entity manager factory for you with your the base package of your application, and we configure a JPA transaction manager because there is none, right? And it just bootstraps and works. It's essentially like you can just even get a feel for what this actually does is if you go with ORM JPA, oh, where is the data stuff here? JPA repositories, autoconf. Let's take that stuff. So there is the use of the new conditional annotations in there. That's probably not a good example. It essentially says, okay, we need to find this class on the class path. We need to find these types on the class path here. So we only register this configuration if these types are on the class path. And if there's a data source present. That's the conditional annotations. Where is the stuff for the data source? Data. There should be JDBC, embedded data source configuration. Right, it just says, okay, there's the configuration. Where is it? Data source auto configuration. And here you have an important annotation saying conditional on missing bean. So all of this magic stuff will just go on if you don't have a data source configuration in your application yourself, right? So the automatic embedded data source configuration will just kick in if you don't actually register a, where is the configuration class? If I go ahead and say, there we go, add bean, public data source foo. I have to return null here. But if you configure a data source yourself, the data source auto setup will of course not be triggered anymore, right? So it effectively immediately goes out of the way if you want to configure something special, but defaults the reasonable things for you, just depending on your class path, right? So you get into some kind of, okay, I pull in the dependency and boot does the right thing for me. That's essentially it. And the last part I want to show you with the application here is that it's very easy to run these applications in terms of, okay, all you need to do is have a main method and call Spring application run application. And that will go ahead and essentially detect, because we have, through the web module, we have embedded Tomcat on the, there's Tomcat, where is it? Tomcat embed core, right? We have an embedded Tomcat in the class path. So when we run the application, we will actually bootstrap a Tomcat for you, and yeah, it's just becoming a regular web application. So the consequence of that is that this thing here, I mean, even if we just took this package as the entire application, this is just a jar file that you can run with java-jar if you just build it with your Maven project. There's also a boot plugin that again turns this into a WAR file, an executable WAR file, but still deployable to Tomcat. So yeah, the bottom line is, okay, we want to make it really that simple to write any sorts of applications with Spring. I mean, if you Any Node Java developers here, like any other languages? Not really. But if you try to make that example and go to some Ruby guy or anyone outside of the Java community and tell him or her what is actually necessary to bootstrap or to create and bootstrap a Java web application. And after 2 minutes, that guy or that gal is just gone, right? Because servlet container, web XML, or servlet application initializer, Maven setup, looking up versions, and then declaring servlets, and configuring this and configuring that. And that's just all gone if you just have this one main method here. There's been some bit of a competition going on on the Twitter profiles of the boot authors. If you write that stuff with Groovy, you actually get rid of the imports, because we can use grape under the covers to automatically pull down the dependencies. And it's really possible to fit a Spring controller and with a request mapping and the main method all into one tweet. So you get an application in a tweet. However reasonable that actually is, or I don't think it's really telling anything about the usefulness in real-world applications, but it's like the why do you do it? Because we can, right? A bit of fun with that. All right, so thank you very much.